Welcome back, everybody. This is Dr. Gallegos at Orion, and today we're in Module 6, Lesson 5. We've been working with radicals, and today we're going to be solving square root and other radical equations. And so before we begin, let's take a little bit of a look at some definition here. A radical equation is an equation that has a variable in a radicand or a variable with a rational exponent. So it can have either one or both, right? If the radical has index 2, so that index 2, meaning the square root, the equation is a square root equation. In today's lesson, we're going to assume that all the radicals and expressions with rational exponents represent real numbers. So let's get to work on solving a square root equation. So if I have an equation 3 plus square root 2x minus 3, and I'm going to set that equal to 8. Let's do a couple of things first. So I'm going to say equal square root of 2x minus 3 and equal 8 minus 3. That's going to get me 5. So I move that over to the other side so I can do a couple of things. Now, if I square both sides, so if I say 2x minus 3, and I square that, equal 5 squared, then that's going to get me the square root of 2x minus 3 squared is 2x minus 3, and then 5 squared is 25. All right, now I can work with this and begin to solve it, right? So I've got 2x equal, and I'm going to take that 3 to the other side, so that's 25 plus 3, that's 28. So I've got 2x equal 28. Let's put both sides divide both sides by 2 so we can begin to solve for x. So then we have x equal 28 divided by 2 is 14. So that's how I took this radical square root equation and was able to solve for it. Now, I've got a value for that, and I've got 14 there, so we can check our work here by just substituting that 14 back into our equation to make sure that it works, right? So I'm going to put my line here, and I've got 3 plus the square root of 2 times 14 minus 3, is that equal to 8? All right, so I've got 3 plus the square root of 2 times 14 is 28. 28 minus 3 is 25. Is that equal to 8? All right, square root of 25 is 5, so 3 plus 5, is that equal to 8? 8 equal 8. So that does check out. So the way that we approached our problem here does work out. All right, let's put a little bit of a kink in it and make sure that we can still work with these. And in our second problem, we're going to look at a solution for 3x plus 1. And I'm going to take that to the 2/3 power equal 12. All right. So I'm going to take that 3. I'm going to divide first both sides by 3 so I can begin to isolate my variable, right? All right, so I've got 3. I divide that by 3. So that goes away. So I've got x plus 1 to the 2/3 equal 12 divided by 3 is 4. All right, now let's take the reciprocal of that. So I've got x plus 1 to the 2/3. And then I'm going to multiply that by 3/2, and you'll see why in a second, equals 4 to the 3/2, right? Multiply both sides by that. So when I do that, I get x plus 1. 2 times 3 is 6. 3 times 2 is 6. So that's going to get me to the 6/6 equal 4 to the 3/2. And we're going to substitute that in just a second. All right, so that's going to get me the absolute value of x plus 1 over here. All right, because it's plus or minus 1, right? That equals 1 equal, all right, square root of, so now we've got the square root of 4 to the 3rd, right? So that's going to leave us with 8, all right? And then we've got x plus 1 equal plus or minus 8. I'm going to get that 1 over there. So x equal 7 or x equal negative 9, right? So plus or minus. So it's going to be either one of those two. Now we can check our work and substitute both of these in. So I can take it back to my original equation and substitute in, and we've got it to work. So we've solved that radical equation there. Now let's take a look at another radical equation and look at a solution to it. So in this case, we've got 3 fifth root of x plus 1 to the third plus 1 equal 25. All right, so I've got 3 fifth root x plus 1 to the third plus 1 equal 25. So let's rewrite the radical using a rational exponent first, okay? So we've got 3, then we've got parentheses, x plus 1, parentheses, 3 fifths. All right, so that was because we have the fifth root of x plus 1 to the third, so 3 fifths. So plus 1 equal 25. All right, now let's subtract 1 from both sides. So that leaves me, I got that 1 we're going to subtract, so that leaves me 3 parentheses x plus 1 to the 3 fifths equal 25 minus 1 is 24. Now let's divide each side by 3. So we've got 3 x plus 1 to the 3 fifths equals 24, and I'm going to divide that by 3, divide it by 3, okay? So that leaves me x plus 1 to the 3 fifths equal 24 divided by 3 is 8. Now, let's raise each side to the reciprocal, so the 5/3, right? So we're going to say x plus 1 to the 3 fifths, and I'm going to raise that to the 5/3 power, equal 8 to the 5/3 power. All right, so now we see where we're going. That means we've got x plus 1 over here because those cancel out. So x plus 1. And when I raise that 8, so I've got cubed root of 8 to the 5th. That's going to get me 32. And then now I just need to simplify. I'm going to subtract 1 from both sides. X equal 32 minus 1 is 31. So our solution is 31. And to check, what do? We go back over and make sure that it checks out.